Lithium-ion batteries are energy storage devices that contain a liquid electrolyte that can be flammable when they overheat. An alternative to replace these electrolytes for a solid version, however, solid electrolytes have low ion dynamics. An alternative is to prepare composites between organic ionic plastic crystals and polymers because they allow to tune the desired properties. It's expected that these composites will take also advantage of the plasticity and mechanical strength of the former materials, and in addition of the properties of the interfacial regions formed between them, which will mediate the transport processes. The thermal analysis of the composites after adding 10, 20, 30, and 40 volume% shows that the intensity of the endothermic peaks of the organic ionic plastic crystals decrease with the addition of polymer. It means that we are creating a more disordered environment around this material. These results were confirmed with the optical microscope, where we observed in a composite with 20 volume% of nanoparticles that the crystals of the organic ionic plastic crystals are disrupted, and means we are creating more structural defects in these materials. We measured the ionic conductivity of these materials, and we found that in general the addition of polymer nanoparticles increases the ionic conductivity, and also that the composite with 40 volume% shows the highest average ion transport. We also studied the lithium-ion dynamics using solid-state NMR, and we performed static experiments in the composite with 20 volume% of nanoparticles. We found at lower temperatures a broad peak, which means that we have a lower ion mobility at these temperatures, but once we reach 60 degrees, the peak becomes narrow and it indicates an increase in ion mobility. We measure the line width of these peaks, and also we perform these experiments in the composites with 30 and 40 volume%. And we found that the composite with 40 volume% has the smallest line width, which means that in these materials, the lithium ions had higher ion mobility. And for that reason, we think that this is the best composite of this set of materials study. Thank you.